Hello, my name's James Alsop, and I'd like to tell you a little bit about the physics program at the University of Michigan-Flint, what we do well, what opportunities you'll have if you enroll with us, and what our graduates go on to do. All right, so we'll start with a little bit about what physics is, what you'll experience with your coursework here and your research, and where to go from that. So if you're looking at physics, it sort of gets broken up into sort of two major areas, where there's classical physics that includes relativity right here, and that a lot of that is physics that happens on a macroscopic scale, but also you can move in and look at some statistical physics and thermodynamics and some E&M as well, electricity and magnetism. And then there's quantum mechanics inside of it, and that's when you start to sort of zoom in on what's happening inside of nature and trying to characterize it from its smallest little parts. Okay? And then from those you could sort of look into different directions, like where the future of physics is going to go, or also why we're studying the things that we are and how it sort of impacts us. Okay? So that's the groundwork, and we have different areas of our program touch on all of these different aspects inside of it. So the first question that you could ask when you're looking at how to come to the university and do physics, there's sort of these four sort of background things that we look at and we think applies to any area inside of physics and a lot of just different STEM fields. The first thing that you want to do is just sort of be curious. Follow your natural instinct. If you think something's worth exploring, it is in that case. So spend that time to pick it up. Number two, you want to use tools. Okay, those tools could be the mathematics behind it. They could be a nice optics table or a laser setup, or it could be a computer that you would use. Okay. Three, be passionate. Okay, so once you start into your coursework, you want to sort of push it. What you learn in class, push it a little bit more. Learn outside of that and pick up little pieces here and there over years and years. That's going to accumulate to be a lot. And then number four, get your education. So you start with sort of paying your dues, doing introductory physics courses, and then you get to move into modern, and then ultimately to your advanced lab, capstone courses, and quantum mechanics classes and things like that. All right. So specifically at the University of Michigan-Flint, some of the things that we pride ourselves on are our engaging classes. Our faculty maintain an awareness and an interest in the best practices inside of it. And you can see these pictures right here are from our introductory courses, where we use state-of-the-art Zik and DeGraff active learning classrooms, with another one coming soon. But the idea here is to lecture less and use your hands more, and to talk to your peers. So the instructor will get up and lecture for 10-15 minutes, and then hand over problems or hand over labs to the students, and they engage to work on them themselves. And that structure has been pushed into our upper level classes, where you'll see here, this is one of my old statistical mechanics classes. Only 4 students were inside of it. It was an excellent time. They'd come in, I would lecture for 10 minutes out of the hour and 15 that we were meeting for. The rest of it, we'd sit around a table and start to flip coins or in the first day of class, and then eventually start adding up partition functions and things like that. And everybody works very well with each other. It's a very very pleasant system that we have. Okay. All right, so where do our faculty members fit into this picture that we were looking at before? So I'm sort of the resident theorist at the University of Michigan-Flint, and one of the things that I've looked at is black holes and their orbits around one another, and also using them as tools to study other systems. But this was a project I did with some students where we were looking at what happens when a black hole eats another smaller black hole, and we were trying to calculate the trajectory that comes out of it. All right. Next we have Dr. Barman, where he looks at trying to characterize materials and looking for useful sort of band gaps in systems and things like that. So that could be used later on for electronics. Okay. We have Dr. Ganguly. He likes to study the supermassive black holes and understand how they grow to be so supermassive, right? So what are they doing? He uses telescopes, looks out, analyzes the light that we get from the accretion disks outside of them, and from that infers what's going on. Then we have Dr. Vizziri. So he likes to study and manufacture carbon nanowires. So he has these synthesis techniques where he takes some sort of collection, maybe he bakes it, maybe he boils it, maybe he zaps it with a laser, freezes it, puts it into a vacuum chamber. He tries to manufacture these and ultimately extract them for use in, find just nice ways to synthesize them and then use them later on for electronics as well. Okay. And then we have Dr. Eaton, and she's interested in how we learn the things that we do, right? So how does one, when you're taking your science coursework, how does that shape your personality and your ability to learn more after that? Okay. We also, so with those areas, we engage all of our students in research. We have a variety of different opportunities for students to come in. We have a ZIC undergraduate research grant that pays students to come in and work in one of the research groups. We also have a university program called UROP where students get paid to do it, and then SURE as well. And SUREs are nice because you can come in and you sign up, you do research with a faculty member for an entire summer. You could do 9 to 5 for the whole time, or maybe, if that works better, do 9 to 1, 4 days a week or something like that. But it's really an intense job-like experience, which you'll see in graduate school later on. Okay. We also have an active student club, our Society of Physics students. So here's a picture of the society going down to see the total solar eclipse in Tennessee a few years ago. Walking out to get prepared to see it on a lake. This was when Story Musgrave, an astronaut, came and visited us and held many talks to tell us what it's like to go out into space and to work on Hubble when there's really no up or down. We have an honor society built into the student club as well, Sigma Pi Sigma, which recognizes students that come in and perform very well in their physics coursework and also the entire coursework that they go through. Okay. We have access to a wide variety of scholarships. The majority are, as long as all of our students that are making satisfactory academic progress are entitled to $2,000 a year in scholarships at a minimum, and many times considerably more than that too, depending on what else they qualify. So these come from a variety of different ones. We have a ZIC scholarship. There's David Zick. He's been very generous to our program. He's also in charge of the undergraduate research grant as well. That's thanks to him. Students can qualify for a Freeman Scholarship. And then we have the Dowie Scholarship. And this is the one that you come in, you enroll, you receive that $2,000. And as you move through, you could start to get, pick up a few hundred or maybe up to 1,000 more in these other scholarships too. And the Rose Boys to Graph, another scholarship made for our physics majors. The program is also community engaged. We run an Astronaut Activity, which is it's a family-oriented event, and it's sort of an open house, and you take parents and small kids, and they get to explore just the ideas of what's out in space, like what's a comet made out of, how does a supernova work, those types of things. And they get to do arts and crafts and fun things like that. We also have hosted our first UM-Flint high school physics competition, where high schoolers developed a project and then gave presentation on what type of physics it's demonstrating. And then also the SPS group has just been active at regional parks and science fairs. So here they are at the Genesee Science Fair, trying to demonstrate just how much force you can extract from atmospheric pressure acting on some sort of a surface. So our recent graduates with the research experience, our classrooms, the scholarship support, they've been very successful. We have roughly 2 out of every 3 of our graduates over the last 20 years have gone on to receive their PhD or are working on their PhD right now. And they're going to some of the country and world's best universities, right? We have somebody who went to Berkeley, California, Irvine, Connecticut. We have Michigan State, University of Michigan as well. So they go out and they're very successful. They achieve their PhD, and then they work and they're a scientist for the rest of their lives, right? And then we have also moved the rest of our students, the other 1 out of 3 students, into sort of engineering-based and computer science-based opportunities as well, and some high school teaching too. So you come in if you're interested in working with your hands, and you would pursue the engineering one. If you like, maybe you learn something about chemical deposition and that type of thing, and then you would go to maybe more STEM-filled ones. But if you're strong with computers, you've had success working on computer science programs and developing apps and things like that. All right. So that's a little bit about us. If you have any questions, please don't hesitate to reach out. You can reach me by email or our PR advisor by email as well. All right. Thank you.